A new view of the Solar System's early days proposes that the first two kinds of solid materials, the precursors of space rocks and ultimately planets, both formed at the same time. When the Sun was born about 4.6 billion years ago, it was surrounded by a cloud of gas and dust that eventually became the asteroids, comets and planets. An initial step in that process had to be the generation of clumps of solid material. Previously, researchers believed the two known types of early solids formed several million years apart from each other. But a thank you for trying verbose. This recording will go away once the product has been purchased. New dating technique from the University of Copenhagen's James Connolly and fellow researchers shows different results. This means the early days of the Solar System look different than previously thought. Connolly and his teammates proposed their new model in a paper to be published in Friday's issue of the journal Science. Gas and dust compression. Connolly's team focused on two types of solids, calcium-aluminum-rich inclusions CaIs and chondrules. Both of these solids are found in meteorites, which are pieces of space rocks typically billions of years old that find their way to Earth and are often thank you for trying verbose. This recording will go away once the product has been purchased. Discovered by scientists and amateurs. These materials have records in them of events and processes in the early part of the Solar System, Connolly said, particularly of the time that the Sun and planets were forming from a spinning disk more than 4.5 billion years ago. CaIs form from molten gas droplets under temperatures higher than 1880 degrees Fahrenheit 1030 degrees Celsius, or 1300 degrees Kelvin, while chondrules are dust collections that rapidly melt and cool in a lower temperature region of less than 1340 degrees Fahrenheit 727 degrees Celsius, or 1000 degrees Kelvin. Thank you for trying verbose. This recording will go away once the product has been purchased. Under the new model of the Solar System's formation, the spinning disk that eventually formed the Sun and the planets had a large amount of energy within it. Particles were flattening into planes along the disk. In the center, the Sun formed as material lost momentum and began condensing. As the material collapsed onto the protoplanetary disk, huge shockwaves formed that produced flash heating, or warmth that began and then dissipated within a matter of hours. These surges of energy affected the CaIs and the chondrules, Connolly said. The finding could be important, because it thank you for trying verbose. This recording will go away once the product has been purchased. Illustrates a generic way that all protoplanetary disks in the known universe may have formed solids. Other dating methods said that the energy from our Solar System's protoplanets, as they whizzed around in their orbits, predicted the chondrules formed some 2 million years after CaIs did. However, this timing didn't jive with astronomical observations of other planetary systems, which predicted a shorter formation period. The other model, Connolly said, implied there is something unique about our Solar System that allows these inclusions to be formed. It looked as if these things were lasting a bit too long. Thank you for trying verbose. This recording will go away once the product has been purchased. A new method of dating. The old dating method relies on measuring the amount of aluminum-26, which is a radioactive form, or isotope, of aluminum, present in meteorites to date the Solar System. But there is one weakness with this technique, Connolly said. Using this form of aluminum assumes it was distributed evenly throughout the Solar System. If two objects formed at the same time in different locations of the disk, they may not necessarily have the same amount of this aluminum isotope inside of them because there may be different proportions of aluminum. Thank you for trying verbose. This recording will go away once the product has been purchased. In different locations. The old assumption was that if the aluminum proportions were different, they formed at different times. To come up with a new solid history, Connolly and his team adapted techniques he learned at the Royal Ontario Museum years ago while dating zircon minerals. The researchers broke apart meteorite samples, washing and gradually dissolving them to partition lead from the rest of the sample, removing contaminants that can affect the dating process. Connolly's team used mass spectrometers to measure the isotopic composition of lead and uranium, and used a known rate of the decay of thank you for trying verbose. This recording will go away once the product has been purchased. Uranium to determine absolute ages of CaIs and chondrules in the meteorites. Uranium and lead are commonly used to date geologic events on Earth because isotopes of uranium have suitable half-lives, meaning the time in which half the particles decay to lead for this work. In meteorites, using the same process is more challenging because the uranium and lead are in small quantities. However, uranium lead dating is the best method to learn about the early solar system because dating with it is so precise, Connelly said. It can differentiate events that are less than a million years apart. Thank you for trying Verbose. This recording will go away once the product has been purchased. The team's new preferred estimate for the age of sea ice is 4.56730 billion years, plus or minus 160,000 years.